Have you ever wondered what secrets the solar system holds? Mysteries lie in every orbit, in every far-flung comet, and in each rogue moon circling backward around its planet. Today, we're unveiling the tale of a distant star that may have passed through our solar system eons ago, forever changing its structure and reshaping the orbits of moons, planets, and distant objects we're only now discovering.
But how did this star get so close? And what are the remnants of its cosmic encounter?
Join us as we journey billions of kilometers beyond Neptune, where the Voyager probes now roam, and explore how a distant stellar visitor may have come even closer to the Sun than they are today. The passage of this ancient star left clues that we're only beginning to piece together, and its impact still lingers in the orbits of planets, moons, and trans-Neptunian objects.
What might this tell us about our own solar system's past, and what lessons does it hold for humanity's future in space? When it comes to the most distant reaches of human exploration, no missions capture our imagination quite like the Voyager probes.
Voyager 1 and Voyager 2, launched in 1977, were initially tasked with exploring the outer planets, yet their missions have extended far beyond. Today, these sister probes are traveling through interstellar space, having passed beyond the boundaries of our solar system into the great unknown. They've ventured more than 24 billion kilometers from the Sun, or 165 astronomical units, a distance so immense it's almost impossible to truly comprehend.
As they journey further into interstellar space, they also remind us of the mysteries that lie beyond the familiar planets.
And just as the Voyagers push our understanding of what's out there, researchers are realizing that our own solar system may have once hosted a visitor from afar, a foreign star that passed closer to the Sun than the Voyager probes are today. It may sound like the plot of a science fiction movie: a foreign star, traveling through the cosmos, enters our solar system and wreaks gravitational havoc.
But new research suggests that something like this might have actually happened.
Millions of years ago, as our solar system was still evolving, a star came so close that its gravitational pull disrupted objects on the edges of our solar system, potentially altering the orbits of moons, planets, and other celestial bodies.
Imagine the effect of an invisible hand stirring a pool of water.
Objects are displaced, moving in unpredictable ways. The star's influence may have been like that hand, nudging some objects outward while dragging others inward, changing orbits and creating the chaotic patterns we see today in objects far beyond Neptune. To grasp the full impact of this stellar encounter, let's first look at the odd behavior of some of the moons in our solar system. Most celestial bodies orbit in what's called a prograde motion, moving in the same direction as the planet's rotation. Take our moon, for instance. It orbits Earth in the direction of our planet's rotation, creating a stable, predictable pattern.
But not all moons follow this rule.
In the outer solar system, planets like Jupiter and Saturn are home to moons that behave quite differently. Some of these moons orbit in a retrograde motion, meaning they travel in the opposite direction of the planet's rotation, almost as if they're defying the rules of celestial mechanics.
Astronomers have long been puzzled by this. Why would these moons orbit backward, especially when it's so uncommon elsewhere in our solar system?
The answer, scientists believe, might lie in the distant past. Perhaps these moons weren't always part of our solar system but were captured by the gravitational forces of the gas giants during a massive disturbance, a disturbance possibly caused by a passing star. Beyond Neptune lies a vast expanse known as the Kuiper Belt, home to thousands of icy bodies and dwarf planets. These trans-Neptunian objects, or TNOs, hold clues about the solar system's origins and the ancient events that shaped it. One of the most mysterious of these objects is Sedna, a dwarf planet with an incredibly elliptical orbit that takes it far beyond the Sun, so far that it takes more than 11,000 years to complete a single orbit. Sedna's orbit is highly unusual, hinting that something once disturbed it from a more standard path.
But what? A wandering star may hold the answer.
If a star passed through the outer solar system, its gravitational influence could have pulled Sedna and other TNOs into the strange orbits they follow today. Sedna's distant, elongated path through space might be a cosmic fingerprint of this ancient encounter. To explore this hypothesis, scientists conducted over 3,000 simulations, recreating different scenarios of a stellar flyby. Their findings, published in journals like Nature Astronomy and the astrophysical journal Letters, reveal that a star with about 80% the mass of the Sun could have passed at an angle of roughly 70 degrees to the solar system's plane. According to the simulations, this star came as close as 16.5 billion kilometers, 110 astronomical units, from the Sun. These simulations showed that such an event could have caused severe gravitational disruptions in the outer solar system. Objects in the Kuiper belt and beyond were either pushed further away or thrown inward, with a small percentage becoming trapped in the orbits around Jupiter and Saturn. The retrograde moons may be remnants of this event, evidence that a star once visited our solar system, leaving behind a subtle yet profound legacy. The repercussions of this stellar flyby didn't just stop at distant TNOs. Jupiter and Saturn's orbits could have shifted, causing ripple effects that impacted the entire planetary arrangement. The close encounter might have acted like a gravitational slingshot, flinging smaller objects into elliptical orbits and even creating gaps in the asteroid belt.
This event could explain why the solar system is structured the way it is today.
Such encounters remind us that the solar system isn't as stable or isolated as it might appear. Stars passing close to one another may not be common, but they're not impossible either, and this one encounter may have been a turning point in the solar system's evolutionary history.
These findings don't just illuminate the past, they also have implications for the future.
With the advent of new telescopes and missions, such as the James Webb Space Telescope, scientists are on the brink of discovering more trans-Neptunian objects and rogue planets. Some astronomers even suggest there could be another massive planet lurking in the outer reaches of the solar system, influenced by these ancient gravitational disturbances. If we continue to find objects with unusual orbits, it might support the idea that our solar system was once visited by a wandering star, a visitor whose legacy lives on in the orbits of distant worlds. In that sense, the solar system remains a vast, evolving mystery, with new secrets waiting to be discovered. This cosmic encounter with a distant star reminds us that the universe is a place of constant change, with ancient stories written in the orbits of moons, planets, and distant objects. As we unlock these mysteries, we come closer to understanding our place in the cosmos and what the future might hold.
We hope you've enjoyed this journey through time and space.
Don't forget to subscribe for more explorations of the universe's greatest secrets and help us uncover